Welcome to this video, which is designed to introduce you to BeetleBlocks. BeetleBlocks is a new tool for making 3D models. It offers some unique and exciting ways to use simple blocks of code to generate models that can range from simple to incredibly complex. BeetleBlocks is different from most traditional 3D design tools, such as Autodesk 123D Design, currently being shown on the screen. These tools are great for building simple and complex models that start with geometric shapes, and typically we interact with those kinds of models by either dragging out 2D or 3D objects, defining their size, and then using various tools such as Fillet, currently being shown on the screen, to modify those shapes. BeetleBlocks is totally different from this approach, however, and we'll see some differences in the ways that we use BeetleBlocks, along with examples of the kinds of models that it can produce in this first video. One big difference between BeetleBlocks and lots of other 3D design tools is that BeetleBlocks is software that runs in a web browser. Currently, it only runs in Google Chrome, but once you have the website pulled up, you can launch BeetleBlocks directly inside your browser without having to install special software. You can create an account in BeetleBlocks and use this to save your projects directly to your browser or to the cloud. Let's take a look at an example of a first BeetleBlocks project. You'll notice there are three main sections to the BeetleBlocks window. There's the code blocks on the far left, the area where we can connect code blocks in the middle, and then the 3D window on the right. Above the 3D window are several tools, including a green flag and a red stop button. This is how we will generate our 3D models and where we'll see them. As you might have guessed from the name, the star of the show in BeetleBlocks is the Beetle. The Beetle is the object that we use to move around and generate 3D objects. And if we zoom in, you can see the Beetle itself sitting there in the 3D window. Now, in order to make 3D objects in BeetleBlocks, we need to tell the Beetle how to move, where to move, and how often to do it. So we'll start with a code block from the left. Typically, we'll start a program in BeetleBlocks by using some kind of event. The most common event that we use is when the green flag is clicked. So I'll drag the when green flag clicked block into the code window. Now I need to tell the Beetle what to do. So I'll go to the motion category on the left and drag out a block that tells the Beetle how far to move. If I press the green flag, we can see the Beetle move one space. By changing this number, I can make the Beetle move further distances, such as 3 spaces. You'll notice that the Beetle starts moving from the last position that it was at. So rather than going back to the origin in the center, the Beetle will continue moving from wherever it's currently placed. If I want the Beetle to go back to the center and to clear out anything I've done, I can use a special block called Reset. Oftentimes in BeetleBlocks programs, we'll use Reset as a way to make sure that whatever thing we're generating starts from the beginning and clears out anything that might have been there before. So now when I press the green flag, the Beetle will start at the origin and then move 3 spaces. So far, you've seen the Beetle move in just one direction, but because BeetleBlocks is a 3D program, the Beetle can move in any of 3 dimensions. Let's tell the Beetle to slow down a little bit in between moves so that we can see this a little more easily. I'll drag out a wait 1 second block in between each of our blocks of code. So we see the Beetle return to the origin and then move 3 spaces. After the Beetle moves, let's tell it to rotate around the Z-axis, and let's tell it to rotate 90 degrees. So now our Beetle will return to the origin with its reset, wait 1 second, move 3 spaces, wait 1 second, and then rotate around the Z-axis by 90 degrees. The Z-axis is the blue axis that we see right around here, and we'll see what that looks like. So I'll press the green flag, and let's take a look. Notice that the Beetle has now turned 90 degrees, and if we move 3 spaces again, we can see that the Beetle will now be moving in that direction. Again, I'll add a wait 1 second block so we can watch the Beetle a little more easily. Now, in addition to simply moving, we can tell the Beetle to start generating a 3D object, and that's where the real power of BeetleBlocks starts to come into play. Let's take a look at shapes. In our shapes category, we can tell the beetle to start extruding. And extruding simply means leaving a trail of three-dimensional shape behind it as it moves on its path. So after our reset here, let's add a new block called Start Extruding. I'll drag this block in here, and now reconnect our weight block, and let's take a look at what our beetle does now. You'll notice that our beetle has now left a trail of solid three-dimensional object. I can orbit around that in our 3D window and we can see what that looks like. That's not the only way our beetle can move, however. In addition to extruding curves, it can also extrude lines. Let's take a look at the difference between those two. You may have noticed that instead of trying to make a curve between the points, our beetle is now moving in straight lines. There are curves at the edges, but that's simply because what our beetle is extruding looks like a tube or a sphere. If I wanted to complete a three-dimensional square, I could simply tell my beetle to move and turn 2 more times. One powerful tool in Beetle Blocks, however, is the ability to tell it to do those things multiple times with code instead of having to simply drag out blocks multiple times. In coding, a common control structure for doing that is a repeat. We want to move and rotate around the z-axis 4 times to make our square. So we'll drop just those blocks into our repeat. Once we connect up the repeat, we'll take a look at the entire piece of code. We can see now that our beetle has moved all the way around our square, leaving a trail of 3D object behind it. We can also run our code and change it to see what that would look like with a curve instead. As you can see, we've now made a relatively simple three-dimensional object with just a few blocks of code. Let's take a look at some more advanced examples using these same techniques. We'll start our next program in the same way that we started the first program, which is using the control block when green flag clicked to start the program. Each time our program runs, we'll want to reset the beetle, so we'll drag a reset block out as well. Now what we'd like to do in this program is have the beetle move in a circle, or at least close to a circle. A circle has 360 degrees, so we need to tell the beetle to move 360 degrees in a circle, which means a combination of moving and turning to do that. Just like before, we'll use a control block called repeat in order to tell the beetle to keep doing the same motions over and over. Let's drag our repeat out, and since 360 degrees divided by 10 is 36, we'll tell the beetle how to move using that number. We'll tell the beetle to move 1 space and then rotate Z by 36 degrees. 36 times 10 gives us 360, so let's take a look. In order to see more clearly what the beetle's doing, we'll use the same technique as we did earlier, and we'll ask the beetle to simply wait 0.5 seconds in between each of these moves. Let's take a look and see if the beetle moves in a circle. It's not a perfect circle, but we can see the general outline. This will be easier to see if we go into our Shapes menu and tell the beetle to start extruding. That will leave the shape behind so we can more easily tell if the beetle is doing what we want it to do. Let's take a look now. As you can see, the beetle definitely moves in a circular direction, but we can see lots of the angles where each of those turns occurs. Let's tell it to do 20 repetitions and change this by half. Now the beetle will make twice as many moves and turns, but each one will be smaller, getting us closer to a perfect circle. Let's take a look now. Because we can pretty easily see what the Beetle is doing, let's get rid of those weight blocks. One thing that can be a little tricky with Beetle blocks is that we have to detach the blocks that we don't want from the bottom to get rid of them, and then drag them away. So I'd like to get rid of both weight blocks. I'll drag them back over to the side, and then reattach my rotate block. That will make our Beetle move a little bit faster so we can test this out. So we've made a pretty nice looking ring, but let's add a few layers going up of the same ring. If we want the Beetle to do that, we need to tell it to not turn, but move its Z position. In other words, we want the Beetle to move up in the Z axis after it's made this first ring. We can do that with a different motion block. Instead of turning or rotating in the Z axis, we'd like to change the absolute Z position of the Beetle, meaning we want it to move up one space in the Z axis. So after it does this, let's change the absolute Z position of the Beetle. Let's run this and take a look. You notice that as the Beetle moves up one, it already starts extruding this little bit right in here in the next layer. And let's see what this would look like if we did this 2 times. Just like before, when we want something to happen more than once, instead of simply dragging out those same blocks over and over, we'll go to our control structure and we'll use a repeat. We'll put both of these blocks inside of our repeat, and let's look at what this would look like if we did this 3 times. Here you can see that our Beetle has left 3 sets of trails, but because we're doing our change absolute Z inside our repeat, what's happening is that the Beetle is using this to rotate and move in its circle, and then change this. We're getting an extra little nub at the top. So let's do this. After our Beetle moves in its circular pattern, let's tell it to stop extruding. That way, when it moves up, it won't leave that extra little nub at the top. In order to do this, we're going to move our start extruding block into this repeat. And what we'll do is tell it to stop extruding before it changes its position. So now what our code says is to repeat this 3 times, start extruding, move in a circular pattern, stop extruding, move up by 1. Let's take a look. You'll notice that our Beetle is still there in the middle, hanging out right above our rings. Now, if we'd like to take this one step further, we can get some input from the person that's running the program. So instead of 3 layers high, our ring structure can be as many as we'd like. And we can do that by getting some input from the person that's running the program. Let's say that when the green flag is clicked, we'd like to find out how many layers this structure should be. When the person types in an answer, that will appear as this block right here. This is a variable that BeetleBlocks comes with that just lets us get the information that the user typed in. One thing that would make sense here is to switch the positions of our reset block and our request for user input so that the screen is cleared before we get our user input. Let's click the green flag now. How many layers high? Let's try 5 this time. So what you've seen now is a powerful way to use a few relatively simple blocks of code to make a relatively complex object. We could do this with a traditional 3D modeling tool as well, but this gives us a very different way to approach 3D modeling. Since one of the really interesting uses of 3D modeling is 3D printing, let's take a look at what it takes to export a BeetleBlocks model and get it ready for 3D printing. To do this is very simple. We're going to come up to the menu here in BeetleBlocks. We're going to choose Download 3D Model as STL, and our STL file will download. At this point, depending on the type of software we're using to control our 3D printer, the process will look a little different, but I'll show what it looks like using the software Cura. Cura is software that lets us take a 3D model file that's been saved as an STL file and send it to our 3D printer. In Cura, I'll place the 3D model file that we downloaded as an STL file so that it can be 3D printed. So I'll load the model file, and now we can see the object that we modeled in Beetle blocks represented on the bed of our 3D printer. Because it's relatively small, I can scale our model some in order to make it a little easier to see and bigger as we 3D print it. Using Cura's controls, I can also change its orientation by rotating it, and it will automatically update to show me how much time it estimates this file will take to 3D print. Currently, it's showing that this will take 53 minutes to 3D print this object. Let's watch as the 3D printer generates a physical representation of what we made in Beetle blocks. The printer I'm using here is a PrinterBot Simple, which is an inexpensive 3D printer that my son and I actually assembled together. If you're interested, I'll put a link to that video in the description of this video. Many 3D printers use the same type of technology called Fused Deposition Material, or FDM. Basically, these printers work by heating up plastic filament, squeezing it through an extruder, which is the red end shown in the video here, and repeating that process over and over to build up very thin layers over time, so an object begins from the bottom and then is built up with those layers of plastic building one on top of the other. Let's watch the 3D printer as it goes. You can see the 3D printer moving in all three dimensions. The bed of the printer with the blue tape and the object is moving in the X direction. The head of the 3D printer is moving back and forth in the Y direction. And although it's hard to see, over a time lapse like this, you can start to see the object itself being built up, which is a result of the arm of the 3D printer moving up in the Z dimension, just like we saw in Beetle blocks. So here's the finished printed object. You can see that it has 5 layers of rings, just like the object that we designed in Beetle blocks, and it's pretty amazing to be able to pick this up, hold it, and move it around to see something that started off as code turned into a 3D object. Thanks for watching this video. If you enjoyed it, leave a comment below, and I may be able to produce more videos demonstrating some of the amazing things you can do with code and 3D modeling using Beetle blocks.